Hello,
Yes,
hello.
ma'am.
Am I audible? Yeah, I thought because I had uploaded already the 4 videos related to square lamina and triangle lamina, Google Classroom was more convenient to explain you all. So I just thought we will start up with this, but due to some technical snag, we were not able to connect there. We feel this is more comfortable. So the concept wise, I will explain you the problem. Okay, and all of you I have shared the link in the Google Classroom for the problems 4th, 5th, 6th and 7th. Okay, 4 was done, 5, 6, 7 and 8. Okay, so all the 4 problems are available in Mechanical Department YouTube channel. You can go through it and solve all the problems. Okay, total you should be having 8 problems solved of the last class 4 and today's 4 before you come for the next. So this is a practical session where you have to draft it. Do you have at least a sheet of paper and pencil with you people? I told you because if you understand the concept, you can at least draw a rough sketch for that purpose. Okay, so I'll just explain you the problem. Videos are being shared. So related to the plane surfaces, we have solved the problems of triangular lamina, right, all the 4. And the 5th problem we were supposed to, yeah. So this is done. The categories alpha beta problem is done. And this one I'm explaining you, the 5th problem. So you can see it is a triangular lamina of side 25 mm which is resting on HP with one of its corner. So whenever you have the corner, I have explained you the concept how the position will be. So now the same concept has been explained in the video also. I'll just explain you theoretically how to solve over here. So whenever it is resting in one of the corner, you will be getting the true shape of the top view, and when it is told it is resting in HP, you will start with the front view and then go for the top view. So first you will construct the triangular lamina, seeing that the corner is faced first and then the side opposite to it will be faced. So it is a side of 25 mm which is resting in HP. So top view will look like this. So you will do the construction part. So you will draw vertical edge first of given 25 mm side. From this point, you using the compass, you will cut an arc for 25. From this end, you will cut an arc for 25. So you will get the required triangle. You will take the projection above. So when the observer views from here, the A dash will be visible. But here you have two lines, B and C. B will be visible and C won't be visible. So C you will put it in the bracket. So this will give you the top view. So after this, what is being told? They haven't given the inclination with respect to HP, but they have told that the side opposite to the corner is resting in 15 mm above HP. So whenever you have the location of point 15 mm above HP, what you were doing in projection of point used to take 15 mm above XY line. Similarly, you will take 15 mm above XY line and blindly draw a locus. After that, you will leave some space here. You have a locus here drawn like this. You will leave some distance and you will select this point. So this
Excuse me,
point,
ma'am.
yeah, yeah,
Ma'am,
yeah,
ma'am, your
yeah,
voice
please.
is breaking, ma'am.
Now also my voice is breaking. Hello, am I audible?
Excuse me, ma'am. Your
Yeah,
voice
yeah.
is breaking.
Just a second.
Your voice is breaking, ma'am.
Yeah, is it audible?
Yeah.
Okay. So now
Yes,
after
ma'am.
this first stage I've explained you already. So then you will leave some space. Okay. So 15 mm locus you have taken already. So this point you will fix as A dash. After this you will measure what is this distance. Then keeping at this point using the compass you will cut an arc for the distance what you have measured. So that will cut on the locus of 15 mm. So then you will join the front view of A dash, B dash and C dash to this line. Means it is inclined now to angle. In the question the angle was not given, only the position of the locus of 15 mm above HP was given. So after joining A dash and B dash, then you can using the protractor you can check what is the angle, because they have asked to determine the inclination of the lamina to the reference plane. This angle they haven't given, using the protractor you can measure. Then you will take the projection down, extend the projection here also, then you will read the locus which is passing. extend the locus of A, B, C, take the projection from A dash, B dash and C dash. So then read the locus. Locus of A is meeting the locus of A dash at this point. So this will be our A. Locus of C will be meeting C dash here. So this will be our C. Locus of B is meeting our B at this point. So now you have shifted the first stage of the top view to the second stage, but here you can see you haven't got the true shape of it because you have the inclined surface. Here surface was parallel and hence you got the true shape. Here it is an inclined surface of the front view and hence you won't get the true shape. What you will be getting is the apparent shape, and remaining problem is as same what we have explained in the previous problems. So then it is told that the corner on which it rests is 15 mm above HP and it makes an angle of 30 degree to VP. Then you have to take 30 degree to VP here. It is which side has been resting. You have to see that the side opposite to the corner on which it rests. So this is the corner on which it is resting. So this is the side opposite to it. So this side has to be inclined to 30 degree line. So you will take 30 degree line. First you will fix this side CB. Here no need of determining the beta angle. Why? Because it is inclined on the surface, on the edge or the side, not on the median. Whenever the median is told, the true length of the median will be different and the apparent length of the median will be different in the second stage. But here side, you can see the dimension of the side here as well as the dimension of the side in the second stage is also same, and it is of true length, so no need of determining the beta angle. So you leave some space here, fix one point as C, measure this distance how much it is, keeping one end of the compass here, you just cut an arc on 30 degree line. You will get the dimensions C to B. After that, from here to here you will measure and cut an arc. From here to here you will measure and cut an arc. Then you will join and you will get the required apparent shape of the top view from second stage to that of the third stage. Only difference is you have shifting the side here to 30 degree to VP. After that, the procedure is again same. You will take the projection from each locus of the top view above. You have to show the directions. Here the direction is not shown, but see that you will share it, and then you extend the projection from here as well. Locus of C, locus of A, locus of B, locus of B dash and C dash come along the same line. A dash is already on the XY line. Then you have to read the locus. So your C is meeting with C dash at this point. So this will be our point C. The locus of A is meeting with A dash at this point. So this will be A dash. Locus of B is meeting with B dash at this point. So this will be B dash. So then you will join and you will get the apparent shape of the front view. Okay, always you get the apparent shape of the front view only in the last stage, but whereas you will get the true shape in the very first beginning stage only for the top view, and then the apparent shape you get. And in the third stage, in order to get the apparent shape of the front view, you have to incline the apparent shape of the top view in one or the other direction. Either it could be with respect to side or it could be with respect to median. If it is with respect to median, then beta angle comes into the picture. If it is with respect to side, the true length will be the same and you won't determine the beta angle. Many students will be having doubt when to determine beta angle, when to shift it directly. So you have to understand. Always the sides, irrespective of the stages, the true length will be the same. If it is been asked as median, then it will be bigger here, it will be smaller here. Then you have to determine the beta angle. And in case of a square, if it is diagonal, the diagonal will be having the true length here, the diagonal of the square will be reduced. In that case also you have to determine the beta angle. So this is about the fifth problem. So then let us start with a problem in the square lamina. The entire demo of it is being given. You please kindly go through it before solving. I am just roughly explaining you the theoretical concept. Okay. So now a square lamina means you'll be having four sides, all will be same of equal side. If it is told resting on side also it is the same. If it is told resting on edge is also same. And these points are called as the corner. Corner A, corner B, corner C and corner D. Okay, so when it is told a square lamina is resting on one of its side on HP, this square lamina will be parallel to our horizontal plane and it will be perpendicular to our vertical plane. In that case, when you view from the top, you will just see an square. So here it is told as 40 mm. So you will construct a square. It is told it is resting on one of its side. Any side you take will be the same. So you can blindly consider one side. All the sides will be same and you will name A, B, C and D. But when you view from the front view, so this is a top view, right? So when you view from the front, you can see the projection of this and projection of this as a straight line only. So that front view is being focused here as a straight line. So after that you view from here. The observer when he views from here, A will be visible and D is on the same line but it won't be visible. So that you will put it in the bracket. Front view is always associated with A dash, B dash, C dash. So we will write A dash and D dash which is not visible in the bracket. Again you come here, you can see B and C. B dash will be visible and C won't be visible, that you will put it in the bracket. So this is the first stage. After this, what has been told, the lamina makes 30° to HP and the side on which it rests makes 45° to VP. So after the first stage, even in square lamina problem, we have to take the inclination with respect to HP only first. So first you will take a inclination of HP. So you will shift the front view for 30° line. After that, first you will leave some space. You fix this point A dash and D dash. From there you take 30° line. Then you measure this distance how much it is. And then you just cut an arc on 30° line. It meets somewhere. Then you name this as C dash and B dash. After this, you have to take the projection down and show the direction in which it has been projected. Then you also extend the projection line from the top view. It meets at some point. Read the locus. Locus of A is meeting at locus of A dash. Write it as A. Locus of B is meeting at B dash. Write it as B. Locus of D is meeting at D dash. Write it as D. Locus of C is meeting at C dash, sorry, locus of C is meeting at C dash at this point. So then this will be C. So now you can see, since it is inclined, the true shape of the square lamina is now condensed. It will be little bit smaller. So this is the true shape of the top view and this is the apparent shape. We have completed the second stage. And next what is being told, the lamina makes, this is over, and the side on which it rests makes 45° to VP. So this is the side on which it has been resting. Okay, so which is the side A and D. So this side has to be now inclined to 45° to VP. Remember, you can take 45° to VP in this way or in this way, whichever is convenient to you all depending upon the availability of the space in your sheet. So here it is shown, it is taken 45° in this way. Sorry, it is taken 45° in this way. So 45° line is taken here using the protractor. Then leave some space and fix the point D. After fixing the point D, you measure this distance how much it is. 40 mm. No? So keeping one end of the compass here, you will cut an arc on the 45° line. So you will get this edge. After getting this edge, you know that all the sides will be perpendicular in the square. So you got this point, name this as A and D. So from here, keeping the protractor at point D, take 90° exactly. Keeping the protractor at point A, take 90° exactly. Then you measure 40 mm and you cut an arc on this 90° line. Similarly, measure 40 mm. From this, you cut an arc. You will get the point B. So then you got the point A, B, C and D. So you will join A to B, B to C, C to D and D to A. So this helps in shifting the apparent shape of the square lamina for 45-degree line. Here also beta angle is not calculated. Why? Here the side is been shifted to 45 degree to VP and not the diagonal. So if you join A to C and D to B, these are the diagonals. So those diagonals here get compressed. And if suppose it was told the diagonal AC has to be inclined to 45 degree to VP, then the diagonal here in the second stage will be compressed. In that case, you have to determine the beta angle. Since it is only with respect to the side inclination, the true length in first stage of AD and true length of the second stage is also same. You can notice it is also 40 mm and this is also 40 mm. So whenever the true length of the side remains the same, you will not determine the beta angle. Okay, and hence you will directly shift. After doing this, the procedure is same. You will shift the locus of A, locus of B, locus of D and locus of C, and extend the locus of C dash, B dash, extend the locus of A dash and D dash. So it will meet at different corners. So locus of A is meeting locus of A dash at this point. So this will be our A dash. Locus of B is meeting B dash at this point. So this is our B dash. Locus of D is meeting D dash at this point. So this is our D dash. Locus of C is meeting C dash at this point. So this is our C dash. So you join all A dash, B dash, C dash and D dash. So finally you will get the apparent shape of the front view in the third stage. Okay. Always notice in the first stage you will get the true shape of the top view. In the second stage you will get the apparent shape of the top view, but still you won't get the apparent shape of the front view. To get the apparent shape of the front view, always the question will be given such a way that either the side will be inclined to VP or the diagonal will be inclined to VP, such that it helps in getting the true shape, apparent shape of our front view also. So this is how you have to solve the problem. So next problem is, it is also on square lamina. So it is a square plate of 30 mm side which rests on HP such that one of the diagonal is inclined to 30 degree to VP. So the position of the square lamina should be kept in such a way that the diagonal will be inclined to HP. If the diagonal has to be inclined here to HP, the projection what you take here should give you the diagonal dimension as the front view. For that, if you keep the position of the square lamina in a regular thing, you won't get the diagonal AC. See, you have A here and C here. When you project, you are getting the dimension of one of the side here, and the dimension of one of the side is been inclined to 30 degree. But in this question, what is been told, the diagonal is been inclined to 30 degree. So if you have to get the diagonal inclined to 30 degree, you should be getting the dimension of the diagonal here as the front view. So if you have to get the dimension of the diagonal as the front view here, you have to rest the square lamina in one of its corner and not on one of its side. If it is side, this will be the position. If it is resting on one of the corner, this will be the position how you will be placing. So you can see that you have the diagonal A to C which is projected directly to XY line. So our front view here is measuring the diagonal dimension so that this diagonal can be easily shifted to 30 degree to HP as it is told in the question. So you will construct the square lamina. So to construct the square lamina resting of the corner, always you will fix a point here, draw an horizontal line, take 45 degree from this side and 45 degree from this side. So this included exterior angle will be 45 and this exterior angle will be 45. After that, you see the dimension, the side is 30 mm. So on this 45 degree line, you will measure 30 mm and cut an arc. Similarly, here you measure 30 mm and cut an arc. And you will name it as A and C. So from here you take again 90 degree. From here again you take 90 degree. It meets somewhere. At that point it will be D. Or else on this 90 degree line you can again measure 40 mm and cut an arc, 40 mm and cut an arc. Where it meets will be point D. Then you will join all these points and then you will take the projection above. And while naming, be careful. So when the observer comes